Greetings everyone. I am Neerav Gujati, roll number 143, and the topic of the paper I am studying today is a systemic review of data models for the big data problem. This paper aims to divide and classify data models and their applications. So let's get started. Abstract. This section explains the need of the paper and what the paper entails in a small yet conclusive summary. The amount of data generated today is increasing at a rapid pace. Thus, it becomes necessary to study the present data models in order to best structure, organize, store, and manipulate big data. The paper thus tries to review and analyze various types of data models and their applications. In order to address the need, they have also developed a systematic review method to classify and present the different types and characteristics of data models. So, relational database management systems (RDBMS) were once thought to be the best solution for many data consistency and management services, but the results were worthless and inconclusive when applied to complex data because they relied too heavily on Cartesian products. As the volume and variety of data increased over time, relational data models ran into scalability issues and lacked open source databases and support for all data structures. Since then, newer data models have been proposed and developed to remedy such deficiencies. From XML models to NoSQL data models have been developed to fill the need to substitute new databases for the old ones. Some of the features of NoSQL databases are high scalability, availability without the need for ASCID feature support, open source capability of the presented models, and dynamic data modeling capability. The amount of data generated today is rapidly increasing. As a result, it is important to investigate the best data models to best structure, organize, store, and manipulate data. The lack of this has led to a waste of time and energy in the industry in deciding which software to use and how to best support them. The background of the paper highlighted the key concepts and terminologies associated with big data, data models, and schema. Big data concepts. The big data refers to data sets that are too large or complex to be dealt with by traditional data processing application software. It is data with greater variety arriving in increasing volumes and with more velocity. The high volume, high variety, and high velocity of data have recently posed the challenge of 3 V's to this field, also known as the big data problem. The big data problem is not a single isolated problem but a culmination of them. The problems can range from having a data set that grows exponentially over the time to having to integrate data from various sources, and even security concerns over maintaining such large data sets. Here, the problem being analyzed is the problem of storing and using big data in a way that is useful and simple for different applications. Data model concepts. A data model is an abstract model that organizes elements of data and standardizes how they relate to one another and the properties of real-world entities. The data model includes 3 major concepts. Data model is a set of data structures that mainly describe data types, properties, and relationships. The data structure is a basic part on which operations and constraints are structured. The data model is a set of operators and inference rules that mainly describe types and methods of operation in a particular data structure. Third, the data model is a set of comprehensive constraints that can be used to describe syntax, dependencies, constraints of the data to ensure its accuracy, validity, and compatibility. Schema concepts. The term schema refers to the organization of data as a blueprint of how the database is constructed. The database schema is a database structure described in formal language supported by the database management system (DBMS). In general, databases can be categorized into 2 groups: schema-based and schema-less. The former utilizes a schema to describe the structure of the database, while there is no need to predefine a specific data structure for the latter, which leads to higher flexibility of the database. NoSQL. So NoSQL is a database management that comes up frequently in the paper. So it is important to define it as well. NoSQL is an approach to database management that can accommodate a variety of data models, including key value, document, columnar, and graph formats. A NoSQL database generally means that it is non-relational, distributed, flexible, and scalable. Additional common NoSQL SQL database features include lack of database schema, data clustering, replication support, and eventual consistency, as opposed to the typical ACID, atomicity, consistency, isolation, and durability, transaction consistency of relational and SQL databases. Research methodology. In this section, explained the research methodology of the authors. First, the research needs were identified in the identification of needs section. In the identification of needs section, the following analytical questions on the types of data models proposed in recent years were aimed to answer through the paper. Why are data models of importance? How are data models classified and the rationale behind this classification? How are different types of data models compared and application of each type? Which kind of properties are required for data models, and what are the future research directions to be followed? Next, the related articles were collected and then refined based on the identified needs. So, in the selection of resources section, the parameters for selection of various papers were highlighted and defined. The articles were first sourced from leading scientific publishers on the topic of data modeling. Then the papers which were irrelevant or were unrelated to the problem statement were ignored or dropped. Only articles published between 2014 to 2020 related to data modeling in databases and data model applications were covered. After that, the key questions to extract from the articles were identified in determining research questions section. In the determining of research questions, the following questions were identified to help analyze the papers more thoroughly. What is the new data model proposed or the data model applied in the article? What is the reason behind, if there is any, comparison drawn between the proposed data model and the other data models? What is the application of the presented data model? What is the design data model intended to achieve? What are the critical features of the studied data model, and what is the comparative result? Which type of supported data, including structured, semi-structured, unstructured, and mixed, is used in the data model? Which type of schema in the study is referred to? Review of the selected articles. In this section, summaries of various articles were selected. Summaries of the various articles selected in the previous section were provided. These papers were very comprehensive and identified different applications of different data models. Many papers contained the comprehensive use of NoSQL and utilized it in managing different data sets. Many other data models were also mentioned, such as Open Scalable Relational Data Model, a Graph-Based Meta Model (GSMM), Big Spatial Vector Data, an encrypted graph database called GraphSE, which was used in creating social media networks, and many more. Each paper highlighted different ways in which big data is used for industrial applications, from social media sites to mapping algorithms, from basic software to development of AI/ML databases. Results and comparison. This section identified the results and comparison of the study conducted by the authors. It organized various data models based on the kind of data it stored, how that data was stored, and the features that the data model can provide for various industry applications. In database classification, the models were classified into three main types: time series, relational, and NoSQL. NoSQL was further classified into key value, document based, column based, graph based, and native XML. NoSQL systems are a very heterogeneous group of database systems. It can be said that there are a total of 16 different data models to date, of which 8 are subsets of NoSQL. Based on the reviews and results among all the products in database classifications, MongoDB and Cassandra were the most applied in recent years, followed by relational and Redis databases. As a result, document-based and key value are the most widely used classifications. Today, data streams from sensors, networks, IoT, and so forth account for majority of the data volume. As time series data models are required for real-time or low latency processing of data streams, MongoDB is discussed to be a suitable database. In the data model features section, the different data models are classified in the database classification system section were judged on their application. The parameter for this were scalability, the data model efficient performance on multiplied size or scale. Performance, the data model efficiency in terms of data production, volume and velocity, and big data processing. Representation, the data model management of heterogeneous data, making them meaningful for analysts and commentators. Consistency, the new model capability with previous data models for data integration. Flexibility, the data model's ability to provide support for various data structures. Schema-based or schema-less, the data model's ability to have limited types of data with static and predefined schema, or unlimited types of data with dynamic schema according to the definition of the relation. Data partition, the data model is capable of horizontal and vertical partitioning at any time to ensure data availability and concurrent access performance. Support for data types, the data model's ability to store structured, semi-structured and unstructured data based on the variety of big data. Hash, a technique to directly search the location of desired data on the disk. Efficiency, the data model has necessary efficiency in many processes on data, and database uses a small amount of computational and storage resources. Availability, data should be available whenever necessary. The determining factors in data model design considered are consistency, availability, and scalability. It can be inferred from the results that NoSQL databases constitute the dominant group concerning the coverage of key features and variety of products in different applications. The relational model takes second place, and both models are merely adjacent in terms of the efficiency feature. Conclusion. The exponential expansion of data generated from many sources, the large volume and variety of data generated, and the rapid transfer from digital technologies resulted in the creation of big data, the 3 V's issue, and the development of software tools to address this challenge. A data model is required to define the data structure and storage as a way to meet the challenges of big data in the field of data storage and management at abstract level of database design. According to the findings, the research focus has primarily been on classification of data models, storage of various data types and variety, support capabilities and basic features of data models, and popularity and basic technology in recent years. The findings of this review will also be useful to users not only in database and data storage domains, but also in domains of big data, cloud, data migration, and so on. The benefit of this article is that it allows you to compare data models based on their critical features and corresponding products. This article demonstrates the importance of data models even in no SQL database that lacks static data models and flexible schemas. This concludes the end of the research paper study. This project was incredibly insightful and thought-provoking, and I learned many new ideas from it. I thank my teachers and colleagues for this incredible opportunity.